Okay, so this is the hardware setup for the 7-segment display, the multiple 7-segment display. Here in the middle, we have the multiple 7-segment display, which can display 4 characters and 4 decimal points. It is connected to the Arduino. It consists of 4 digital pins, which connect through resistors to the 7-segment display, and then the elements of the 7 segments are connected through all these wires to the Arduino from pin, I think, have a look, 6 onwards. So pin 2, 3, 4 and 5 is the digital pins which control the 7 segment and then make it switch between the 7 segments in order for it to display. Okay, so this is the code which we use to drive the segment display. We're specifically using the library called 7seg, and this is specifically the example that comes with its 7-segment counter. Here we include the library 7seg, which you can download, which you have to download. We create an object called 7seg. It'll come later clear on what to do with that. In the setup part, we just give values to the parameters of the 7-segment object. So we're using 4 pins, what the digital pins are on Arduino, what the 7-segment pins are. Each of these 7 segments control an LED on a 7 segment, and then the last one is for the decimal point. And here is the I told you you don't have to put the resistors on the digital pins or on the LEDs. Here you tell the program false means I put it on the digital pins, or false, it's on the LED itself. I have a common cathode, and we don't have to update with delays because it's refreshing anyways, and we want to keep the leading zeros. Now in our object, to begin is just initializing all these values that we outlined here into the object, and we're also setting the brightness to 90, which means the brightness is 90, so we are sending in a PWM signal that limits the variable voltage and then current to the LEDs. That's why we don't need the resistors on the LED itself. In the main loop here, we start with making a variable called timer, which is millis. Now millis is the amount of milliseconds from the start of the Arduino. Once you turn it on, it starts counting. And another variable called deciseconds, and we want a decibels, we can only display that much as 0. Here in this if statement, we start by if the milliseconds minus the timer, which is at the start of the program, or when the Arduino switched on, if the current milliseconds is greater than 100, so we need 100 milliseconds, And then on the timer we add 100, and that is now desiseconds. So we increment the desisecond variable. So 100 milliseconds is equal to 1 desisecond. And now the second if statement, inside this if statement, we ask if there's been 1,000 desiseconds. If there has, then we reset our timer back to 0. And then out of this if statement, still inside the big if statement, we send the number of the desiseconds to the 7-segment display, and we tell we want 1 decimal place. And then out of the if statement, we refresh the display, and that in order to make a desisecond counter on, as you've seen, using our multiple 7-segment display.
While the code is downloading, it's not necessary to connect the Arduino 7-segment display to LEDs, just as long as you have the current resistors on the digital outputs. There it's running. It's a timer that counts from 0 up until 100 and it then goes back to 0 again.